Hello everyone. Today we will discuss about the psychrometrics. What is psychrometrics and what are the applications in present world, and how you can use the psychrometric chart for your analysis, for your designs, especially in HVAC, heating, ventilation and air conditioning systems. So we will start from the definitions, what is and why and how. So three key points: what, why and how we use psychrometrics and psychrometric chart. So for this way, psychrometrics is the science which basically investigate the moist air dynamics. We are discussing in applied thermodynamics this topic. The reason is that the moist air changes the behavior with the change in the heat. So normally in our daily operations, in our heating, ventilation and air conditioning systems, we deal addition of heat or the removal of heat. In both scenario, we also discuss and the Boyle's law, the isothermal behaviors and the Dalton's law, which we already discussed in previous lectures. And addition to this, we also discuss the sensible heat, the latent heat, what are the differences and how we can evaluate them, and we can use the psychrometric chart for our design perspective in HVAC. Okay. So the psychrometric chart basically the graphical representation of our isothermal, or you can say the behavior of moist air with the change in the temperature and the moisture. So the all unknown parameters we can predict from our psychrometric chart. We only need two values of independent variables like dry bulb temperature, wet bulb temperature, any two, and we can predict the other unknown variables from this psychrometric chart. And we also can estimate uh, if two conditions we want to move towards our comfort zone in any HVAC conditions. So for that purpose, we can predict, even though our refrigeration system, our air conditioning systems, how much load capacity you have to require and what trends will you follow. So for that purpose, firstly, I will move from latent and sensible heat. And if we focus on the words, the sensible heat mean which we can sense, like our thermometers can sense what is the temperature now. So any change which we can sense with our thermometer, we can predict in as sensible heat. So if you see in graph, here is the -40, -20, all are the temperature variations which our thermometer can sense. But when the temperature approaches to zero, and there is, you can say, horizontal line. So this change in enthalpy or internal energy, but there is no change in the temperature actually. The reason is that all the heat is utilizing in converting the ice into uh, water, solid into liquid. So here is the phase change phenomena. This horizontal line shows there is a phase change phenomena occurred which convert ice into liquid or water. So the all energy or heat which you are supplying in this section, all is utilized for change in the phase of the material, or in this case this is the water and ice into water. So you can't predict. So if you in previous classes you may read this phenomena as a Makhfi energy, Makhfi hararat, or you can say we in current situation we in technical term we say it latent heat. So here latent heat in context of in some articles you will read is like of freezing energy or heat of fusion. So how much energy you have to extract to convert liquid into ice or ice into liquid. So both energy will be in the form of latent heat we will recognize here. And the same way, when the all ice convert into water, you can again see a diagonal line, and the temperature is rising up to around 100 degrees Celsius. It means these all ranges you can predict from your thermometer. And at the stage of boiling point of the water, the temperature will remain same, but the energy supplied to the system or this water will be convert water liquid form into vapors. So the phase change again occurred. So you can also say heat of vaporization. The heat supplied will be considered as heat of vaporization, convert water into vapors. So this heat will also not recognized by your thermometer, but you are adding the heat. Like in your daily, you have a breakfast or some cooking in your home. So you will check when the water boil, so the temperature sustained, but the evaporation increased. The vaporization of water increased at that limit. And we mostly use the oil in our home because they have more heat energy, heat capacity to store heat inside. Their boiling temperature is more above than the water. Otherwise, water never sustain more temperature at after 100 degrees Celsius. So you have to see the phenomena in your kitchen daily life that all the heat is converting water into vapors. So here one concept is clear. There are two kind of energy we can say here in the form of heat. That one is the sensible heat, which we can predict from our thermometers, and second one is the latent heat, which is basically the change of the phase of the material, which can be solid into liquid or liquid into gaseous or vapor form or vice versa. Okay. So after that, I want to discuss one by one all the parameters which we have to predict with our psychrometric chart. As I already mentioned, psychrometric chart is the graphical representation of all our thermal behavior, thermal dynamics of moist air. What happened when any heat added in the system, and what happened when heat released in from the system, and what happened if moisture added or removed from the system. So there are mixture of phenomena which directly or indirectly affect the parameters like dry bulb temperature, wet bulb temperature, enthalpy of the system, or the relative humidity, absolute humidity, or you can say the humidity ratio, and the vapor pressures. So all these parameters we will discuss one by one. What are these parameters, and how we can predict these parameters from our psychrometric chart. So firstly, the two parameters labeled here, the one is the dry bulb temperature. Normally with your thermometer, which you normally measures, actually this is the dry bulb temperature. And the wet bulb temperature is a little different, as you see in the picture as well. The bulb, the sensor part of the thermometer will covered with the wet wick, just like I can show you here in our lab. We hang this kind of thermometers there is a combination of two thermometers. And if you see, the structure of both are the same, but the little difference is the wick. Just like here, the wick which is dipped in the water. So what happened here? The water absorbed in this wick, and the bulb environment is fully saturated with the water vapors. So you will get two temperatures with these thermometers. One in a normal condition, that will be the dry bulb temperature, and the second one with the wetted wick, that will be our wet bulb temperature. You can also see the name mentioned as per their characteristics or structure. Wet bulb mean their sensor bulb will be covered with wet wick. Okay, so the two temperature you can observe here. Normally, the dry bulb temperature will be higher. Obviously, if any saturated environment will be provided to the same bulb, the temperature will be lower. So you will predict one in normal condition, that will be the dry bulb temperature, and the other one will be the wet bulb temperature at the same room condition or same your location environment, ambient conditions. Okay. So the next we have to discuss the other parameters. The first one, the dew point temperature. So the same, the title will, you can say, the predict you the picture behind that. Why dew point temperature? Because this is a level at which the moisture in the air will condensed. So also in the picture, in morning the temperature is lower, and the moisture from the air condense on the leaves of the plants. If you get up and early on the morning in any day, you will see the in our words shabnam you can say in Urdu language. So this is the dew you will see in our plants. So the temperature at which the water available in the air will condense. So we have to predict the level before designing the system for that environment actually. So the second one is the relative humidity, the amount of moisture that a given amount of air can hold, and it is the ratio with the can be hold, actual holding or can be hold. So this will be the percentage value. So in first phenomena, if suppose there is a 50% and the other if fully saturated, so obviously the relative humidity 100%. It means now the air don't have the capacity to hold more water at 100% relative humidity. So if any addition of moisture in that scenario will directly condense the water. So there will be the air don't have the capacity to hold in that specific ambient conditions. So in next, the humidity ratio, this is actually by weight ratio of the water vapors with the dry air. How much water vapors in the air comparing to the whole volume, whole weight of the dry air. So by weight comparison will be humidity ratio, or the second name we also mentions in some books is the specific humidity. So both are the same. Never confuse in your next slides. Okay. Other parameters, of course, the specific volume and the enthalpy, the heat, which we already seen in our previous slide, the latent or sensible comparison. So you can see you even never predict the temperature, but the heat is adding in the system. That is increasing the enthalpy of the system. So the both x and y graph, x and y axis shows one is the temperature and other is the enthalpy of the system in previous slide. Will you anybody describe Z? You will describe, but the dew point actually. Will you tell me the dew point? Yeah, dew point, anybody? At which the vapors condensed, at which air can't hold vapors inside. So the any addition of moisture, the all the vapors will be condensed after 100% saturation line or 100% relative humidity. There is no capacity in the air to sustain the moisture. So that point will be the dew point in that conditions. Okay, psychrometric chart, when two properties, any of which we discuss 6, 7, 8 properties about our psychrometrics, and if we know only two, we can just like we can use our wet bulb or dry bulb thermometers, and we can predict easily the ambient conditions of this classroom. So we can predict, we can measure the dry bulb temperature and wet bulb temperature. So after that, we just use these 2 points, two values of dry bulb and wet bulb, and we can predict all others with the use of the psychrometric chart. This is the beauty of psychrometric chart. So the other objective in our today's lecture is how we read, how we use the psychrometric chart. So I am showing you in Celsius scale the dry bulb temperature, wet bulb temperature available here, and what are the curves presenting what variables, what parameters. So you have to memorize that what curve, what axis is displaying which kind of parameters. So here, first, in some graphs, there is mentioned clearly the variable names, what parameter is this. But when you are going to find a point or a combination of a different points or predict the line curves of a process, so sometimes you may confuse. So for that purpose, there is some practice needed to memorize this reading the psychrometric chart. So we will start from this. If this is the dry bulb temperature, the x-axis, this all is the dry bulb temperature line, and here is the humidity ratio. You have to see humidity ratio, which we discussed in last slide, and the dew point line. This is actually the last line here is mentioned is the temperatures. This line actually the dew point line, 100% saturation curve. Here the humidity is 100% relative humidity. You can see the relative humidity curves. These are curvy lines, all are the relative humidity, start from 30, 40 and up to the, this is the 100% relative humidity line. So you can see here the limit of the air is full. There is no addition of moisture can sustain in the air, 100% relative humidity. So this is also, you can check the dew point. Suppose if there is a point here, so if you want to check the dew point at this temperature, then you have to follow the horizontal line straight touches to the saturation line. So this will be your dew point. You have to move from that point to horizontally and touch to the saturation line. So most of the student confused with dew point and wet bulb temperature. Wet bulb, actually these are the diagonal blue lines. So when you have to suppose, I say that 20 degrees Celsius is the wet bulb temperature, and the 25 is the dry bulb temperature. So here is the 25. Here is the 25. You have to move straight vertically up to the level where the diagonal wet bulb lines cross this vertical line. So here are the blue wet bulb lines, 20 degrees Celsius. You have to follow this line. And here 25 the bulb temperature, or here they cross each other, and this will be the your main focus point predicted from two given variables. So when you predict the one point, you can easily judge the other parameters. Suppose there are the vertical curvy relative humidity lines where the point is lie, you can predict, and the relative humidity. These stair like condition is actually the enthalpy line of the air. So you find the point, then you can diagonally, just like the wet bulb line, you have to follow the same line and touch to the enthalpy line. There are two sides. There is enthalpy lines this way, and this all are the same. Just for your you can say help, you can use your scale for initial practice. Even though in currently there are many softwares available, applications available, you just have to put your two known parameters. They can draw the whole chart, the whole process diagram, but initially you have to strong your basics about the psychrometric chart. Otherwise, you can't predict the original design concepts from that software or applications. So for initially, you have to draw on your printed pages. I already provided to you. At the end of lecture, we can also have in class assignment. Okay, so the specific volume curve, another diagonal lines, you can see the green one. These are the specific volume lines. There are mentioned specific volume at different stages. So the enthalpy line, specific volume line, saturation curve, we all can see in this our graph. Okay. So the same I again mentioned for your memorization, the enthalpy side, your relative humidity curves, your wet bulb specific volume, dry bulb temperature, dew point, your touches to your saturation line, and here is the absolute humidity or humidity ratio. Both are the same. Okay. So we have to practice one example. Suppose I give one scenario. There is a dry bulb temperature is the 30 degrees Celsius, and the wet bulb we have suppose in our lab we use both thermometers, and one give us the reading is the 30 degrees Celsius, the dry bulb temperature, and the another one is 25 degrees Celsius, the wet bulb temperature. So if we draw the line, so the dry bulb temperature at 30, you will construct this line. There is the 30 degrees Celsius dry bulb temperature, and you have to draw the vertical lines. Second is our wet bulb temperature is 25. So here is the 25 degrees Celsius wet bulb temperature. You have to follow this line diagonally, which will end here. Okay. So two lines, initially you draw one point, and this point you can easily predict the other parameters, the unknown parameters, which is the straight you will touch the saturation line. This will give you the dew point temperature, and the same the curvy lines, and you are between the 60 and 70 and most close to 70. So maybe it's 68 to 69% will be the relative humidity on this point. So another one is your specific volume. So specific volume is also the green lines we have mentioned here, and the specific volume curve as per your point you can predict. This is almost 0.88 specific volume quantity. So and the specific humidity or humidity ratio, you will horizontally draw the lines and touch to your y-axis, and here is our specific humidity or relative humidity lines. Okay, so you can predict almost 67% the relative humidity, dew point 23 point, actually this is 20 or this is 25 or almost more than, you can say, here straight touches to the dew point, and the enthalpy is around 76, here is 75, almost 76, and specific volume 0.88 around, and humidity ratio 0. This is 0.02, so you can expect that is 0.018. Okay, next, if you check the phenomena in the constructed psychrometric chart, you have seen the trends. One trend shows if we go towards horizontal in right direction, the dry bulb temperature increases. This is in Fahrenheit. You can say in any, you can take the graph in any scale. Okay. So now this is in Fahrenheit scale. So the dry bulb temperature is increasing when we move towards x-axis in rightward direction. So it means heating phenomena. We are adding the heat, and when we move towards left side horizontal condition axis, so the temperature, dry bulb temperature reduces, mean there is a cooling effect, you are extracting heat. And the same when we move upward from this point, we see the relative humidity curves increasing. Here you can see 40, 60, 80 and 100. When we move upward, top side in the psychrometric chart, the humidification, moisture is adding in the system. The trend shows. So we can say the humidifying process. And when we move downward, the relative humidity curves are decreasing, relative humidity decreasing. It means you are extracting moisture, or the relative humidity of moisture is reducing. So it means dehumidifying. So this four combination also show you another perspective, just like a direction east, west, north, south. So this is plus sign. But if we move towards force, cooling and dehumidification between this line, then we can say cooling and dehumidification. Just like we can say east or north, east or south. Same way, this is the cooling and dehumidification region. Same way, this is the heating and dehumidification region. And this is the humidifying and heating region. And this is humidifying and cooling region. So you can divide the sections or the trend lines in perspective of the process, thermodynamic processes, what are happening in the psychrometric curve lines. Another point you will see, the change in temperature, the increasing in dry bulb temperature or decreasing in dry bulb temperature, you can easily predict with your thermometer. That is sensible. That is sensible heat. But when you move from upward to downward or downward to upward, normally the dry bulb temperature the same. But what is another change is happening, that is the latent heat. Suppose this point touches to the saturation line, just like in next slide you will see, here is the point, and you are cooling. Suppose you are this room environment, or you are using an air conditioner, and you are cooling the environment with any external source or some condensers or some. So what is happening, the temperature is reducing, so up to the limit you touches the saturation line. And what will happen if again cooling persists? In next slide you will see, if you can say the moisture added and the continue to cool, what happened? The moisture is condensed. The moisture is condensed, and you see in many air conditioning systems there are some that is actually kind of removing moisture. Moisture relative humidity will decreased. So this phenomena happened. This is actually moisture removed by condensation. And what happened the next? You are again heating the just your purpose is to reduce the relative humidity. So the condensation is also one kind of phenomena. You can easily remove the moisture or decrease the relative humidity. So if you see the next phase, the relative humidity is also the change. And the dry bulb temperature also you can see on your thermostat is reduced. So this change actually the sensible, but this is actually the latent. Okay, the next, if we see the latent and sensible heat phenomena in our most air conditioning system, we followed this mechanism, and we also can predict by using this psychrometric. In this applied thermodynamics subjects, we are giving you just a basic concepts of psychrometrics or psychrometric chart, how to use. But in further semester, you will have a subject of HVAC, heating, ventilation, and air conditioning system. So there is a, you can say, uh, thoroughly research and design perspective you will discuss and you will learn in next semester, where you can design any HVAC system, maybe a air conditioning system or any ventilation mechanism in any greenhouse system. So you can very easily use this psychrometric chart to design your system. Okay, in next slide, you will have one practice assignment, and you will do now. You have 2 minutes, and first I will give you the temperature now we have in our dry bulb and wet bulb. Here the dry bulb temperature is the same, is around 30, and the wet bulb is around 27. So you have to use dry bulb 30 and wet bulb 27. So predict the other values, and you have already printed psychrometric graph in your hands, and you all sketch all other parameters, their draw lines, and encircle the specific value on the psychrometric chart, and you will submit your CR in after 2 minutes. Okay, please continue. If anybody have a question related to, can ask meanwhile. Okay, Talha, can you tell me what the difference, or you can show me here, where is the wet bulb lines? Wet bulb lines. You can mention the color. Blue lines, this one. This is the wet bulb lines. So what will be the dew point? What will be the dew point? How we predict from this graph? Can you tell me? The saturation curve. Saturation curve. So horizontally or diagonally? Horizontally. If we just follow the point horizontally to the saturation curve, that will give us the dew point temperature. And if wet bulb, then we have to follow these diagonal lines from that specific point. diagonal lines or horizontal line will give us the dew point temperature. Okay, never forget this. This is a very confusing point most of the time. Okay, you have to submit your sketch graphs after 1 minute, and I will review and give you the feedback. And in next slide, uh, again the review for you to memorize. We have predict and how to rate the psychrometric chart. What are the horizontal lines? What are the vertical lines? What are the diagonal lines? And what are these diagonal lines about predicting the enthalpy? Memorize this. What dry bulb temperature, wet bulb temperature, where we use actually the psychrometric chart, basically hitting most of the design appliances, design your building structures, and the greenhouses, how the heating, ventilation, and air conditioning systems will work perfectly, how much will be the load, tons of refrigeration, many things you can predict and use in your designs in future studies. And another thing in next slide, there are many applications are available, and I already shared at LMS. You can download some softwares and use in your lab book. You have to, I already uploaded an assignment at your LMS, and you have to follow the psychrometric software and these applications, and print out and put in your lab books, so that we can predict that how you will use and the technology and the latest softwares for the psychrometric analysis. And of course, in future, these will be very helpful for you. Okay, any question? We also have a discussion forum, at LMS. You can put your question there and before the next class, and we can discuss at any time. Thank you very much. Bye bye.